3.1 sets. We start with a bunch of examples of sets, set A, B, C, D, E, and F. And more importantly, we have all of this vocabulary. All right. To learn this language, we're going to have to learn all of these symbols. The empty set means nothing, is an element of, is not an element of, is a subset of, is a proper subset of, is not a subset of, A prime or the complement of A, or probably easier, not set A. And then in A means the number of elements in that set. Okay. So on the left side of that box is the sets written as a list. Most students are pretty good at that. You understand that. You've got a list of items, and that's what it is in that set. On the right is called set builder notation. And for some reason, students really struggle with that one. But it's really a good way of writing it if you don't want to take the time to list out all of the items. In set D, it says the set of all X such that X is one of the United States. So if you think about it, we should be able to say the number of items in set D. What is the number of items in that set? How many United States are there? How many states are there? 50. The number of items in that set is going to be 50. Would you want to list them all out? Because I wouldn't. Students hate set builder notation, but it's actually a better way of writing this because I don't want to list out all 50 of the states. So let's look at these examples in example 1. Fill in the blanks. You want to practice saying them the correct way, all right? So how that is said, 3 is an element of blank. So look for an element, or look for a set that has 3 in it. See right here? 3 is an element of set B, capital B. Do not write a lowercase b, write a capital B because that's the way it's defined. 5 is not an element of, and there are multiple ways you could answer this question. What is 5 not an element of? A would work. 5 is not an element of A. The number of elements in A, all you have to do is count. 1, 2, 3, 4, 5. Set B equals, all right? So we can talk about equality. Set B is the exact same thing as something else. And so it's kind of hard. This one's maybe the hardest question so far. But look at set E. Set E says we want the set of all X such that X is a natural number less than 8. Well, natural numbers means the counting numbers. So when you count like this. 1, 2, 3. So we want to count until we get to a number less than 8. 4, 5, 6, 7. That's how we would list out the elements in E. And so if you look at this example 1, set B is exactly the same as set E. Next, we talk about subsets. Okay, subsets. And this is probably the hardest concept. Okay, a subset is like if you just take some or all of a bigger set. For example, if I said set, no, I've already used C, haven't I? Let's go G. Set G equals A and B. Since that's sum of set A, I could say that G is a subset of A. That means I just took some of the items and made a new set, all right? So notice you've got 2 different ways of talking about a subset. There's a subset and there's a proper subset. I kind of look at that as like less than or equal. All right. The reason I didn't put that little bar on there is because I knew there were less items in G than there were in A. There are only 2 items in G, but there are 5 items in A. So if I had made another set and said like set H is A, B, C, D, and E, then I could say H is a subset of A, like this. Basically, when I'm talking about a subset, I take some or all or none of these elements and make a new set out of it. All right. So B is a subset of, there are a couple of different ways of writing it, but you could say it's a subset of E. And I know that's a struggle right now, but we'll see more examples. F is a proper subset of something. Okay, so let's look at F and let's make a list. F says the set of all X such that X is a state bordering Indiana. All right, so think about the states that border Indiana. We've got Illinois and Kentucky and Michigan and Ohio. That's it. So if I said what's in F, you'd tell me 4, right? There are 4 elements in that set. There are 4 elements in that set. So F is a subset of, or a proper subset of D. D was all of the states, and I just took some of those states and made a new set. That's a proper subset. And the difference between this one and this one was the size. Since B and E are the exact same size, I use that little bar to show equality. All right. But since F is smaller and has less items than D, then I did not use that bar. If you didn't know how many items, you could use this one if you don't know. All right. How about this? A is not a subset. A is not a subset of D. Multiple ways of answering that question. I did not take the elements in A. I did not take them out of D, right? I did not take them out of D. So that's really tricky for students, but we'll see some more and you'll see some practice and we'll get there. Subset properties. Property 1, the empty set is a subset of any set. 2, a set is a subset of itself. And 3, a set of k distinct elements has 2 to the k subsets. 2 to the k. If there are 4 elements in that set, then there will be 2 to the 4th number of subsets. We okay? All right. So list all possible subsets for each set. List them all. All right. The way I like to think about subsets is I like to think about it as like gifts. Okay. Let's say you're going to give your significant other a gift. All right. And let me take that ribbon off there. Let's just put a bow on the top. That's a gift. And inside there's a 7. All right. You're going to give them a 7, or you're going to give them a gift of 8. Okay. So those are the things on their Christmas list. All right. And you're going to buy them a Christmas present. So think about the different ways that you could give them a Christmas present. Okay. So this would be the subsets. All right. So what's something that you could give them? Well, you could give them just a 7. Right? Obviously. Or you could give them an 8. Or what else could you give them? Don't think about it as numbers. Think about it as gifts. Okay. Here's their list. This is my Christmas list. What are you going to get me for Christmas? Maybe you get me everything on my list. Maybe you buy them, both of them. Okay. Or there's one other possibility. Nothing, right? You might get them nothing. That's the subsets, okay? So since there are, remember this, a set of k distinct elements has 2 to the k subsets. Since there are 2 items, there should be 2 to the second or 4 subsets. Did we list out 4 subsets? We did, right? Okay. So look at this one. 1, 2, 3 items. There are 3 items in their Christmas list. All right. And we know there should be 2 to the third power equals 8 subsets. There are 8 different ways that you could shop for them, that you could buy them gifts. Okay. And you know, I like to try to do them in this order. Maybe you get them nothing, or just A, or just B, or just C. Or, think about what else you could do. Maybe you get them A and B from their list. Maybe you get them A and C from their list. Maybe you get them B and C from their list. Or one other possibility, A, B, and C. Notice there are 8 of them. 2 to the third power equals 8. There are 8 subsets. And a subset is just what could you possibly get them off of their list. All right. It's some or all or maybe none of those items in that set. Students struggle with that question. Number 4 should be easy. Find the number of subsets. Okay, find the number of subsets. So since there's 1, 2, 3, 4, 5 items, it's just 2 to the 5th power. We don't have to list them all. You just have to tell me how many different ways there are of shopping for this person. 2 to the 5th power is 32. Right? How about set B? How many items are there in that set? There are 7 items, right? 7 days in the week. So this is going to be 2 to the 7th for our subsets. Okay, I don't know that one. 2 to the 7th. 128. Okay. Empty set. Empty set. Okay. How many items are there in the empty set? The number of items in the empty set is 0, right? But that's not what the question says. Okay. This question says how many subsets are there, and subsets is how many different ways are there of shopping for your significant other. Okay. Anybody know the answer to this question? 2 to the 0 power is 1. All right. 2 to the 0 power. The answer is not 0. The answer is 1. Okay. The only possible thing you can do is buy them nothing, right? But that's your one possibility, is buy them nothing. Venn diagram. Now I know you've seen Venn diagrams before, but we'll see some different ones than what you're used to. Normally, when you think of a Venn diagram, when you've seen it in the past, you've always got 2 circles that interlock like this. And normally you're usually concerned with what's in that overlap right there. That's a very common Venn diagram, but that's not the only Venn diagram. You've got all kinds of different possibilities. For instance, in this first picture, you see how this A is completely inside of set B? That's a subset. That's showing you that A is a subset of B, because all of the elements in A are also in B. This next one is trying to show you the complement of A. Or you can say complement, or you can say not A. Not A. What's in the set, what's not in the set. That's the complement. Number 5. Let U equal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A equal 1, 2, 3, 4, 5. B is 2, 4, 6, 8, 10. All right. So U stands for universe. And when we talk about the universe in a problem, we're just talking about what are we possibly even talking about in this problem. All right. 11 does not exist in this universe. Neither does any of the negative numbers. We don't have fractions. We don't have big numbers, whatever. The only thing that we are allowed to talk about in this problem is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's the universe. Forget about everything else. So in this problem, this says what is not in A. So if A is 1, 2, 3, 4, 5, then what is not A? Not A would be everything else. 6, 7, 8, 9, 10. Okay, what about not B? 1, 3, 5, 7, 9. Exactly. If B was the even problems, then or even numbers, then not B would be the odd numbers. Okay. So this next one says not the empty set, not the empty set, and if it's or you can think of it as not nothing. Okay. If it's not the empty set, what is it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Does anybody know an easier way of saying that? I'm sorry. Okay, that's a great way of saying it. All natural numbers less than 11. I want to keep it concise though. I'm lazy. What's the easiest way to say that? Can't we just say it's U? Right? I like that though, what you said about the natural numbers less than 11. That's exactly right. But the easiest way, the laziest way is just that's the universe for this problem. Not empty is everything else. Okay? How about this, a double negative? Not A. It's what? That's A. If it's not A, then it's A. Double negative. Okay? We've got some new symbols. And this, this first one, this first Venn diagram is the one that you've probably seen before. This when people think of Venn diagram, they think about this picture. All right, but it's not the only picture. But we need to notice some new symbols. All right. And this symbol reminds me of the letter N. Okay. It reminds me of a lowercase letter n. And I want you to think about the letter N and think about it as intersection. I know that's lame, but anyway, that is the intersection or the overlap of those two circles. Where do those two sets overlap? Well, it's the intersection, and that's what that symbol means. You've got to know what the symbols mean. Now, other textbooks, this is weird, but other textbooks will give you other symbols, and I've seen it written like a kind of squared off version, and I've also seen it written like a pointy version. But all three of those symbols mean the same thing. They're talking about the intersection. Okay. I also want you to think about this as the word and. The intersection is the part that is both in set A and set B. That word and will be very important for the next couple of chapters. And. Union. A little bit more obvious that this looks like the letter U. Okay, U for union. We don't have to really like stretch our vocabulary to say intersection, but union means or. And so if you notice, the way I read this is A or B. I would color in the part of my diagram that's either in set A or in set B or both. And so that's why this whole thing is colored. Sometimes I call it a dead snowman because it's laying on its side. But that whole thing is covered because either, any one of these regions is going to be in either set A or B. Disjoint. Okay. That's the intersection, but I read it as and. A and B is the empty set. Or there's nothing in the intersection. There is no intersection. That's what that means. All right. So, think about it this way. If you put numbers in these regions, 1, 2, 3. What number, if you've got A is elements 1 and 2, and we want to intersect that with elements 2 and 3. What element or elements are in set A and in set B? 2, right? 2. And that's what we've shown in the picture. That's the colored in part. So same thing here, 1, 2, 3. We've got set A is 1 and 2, and we're going to union that or join that with a set B, which has 2 and 3. So what element or elements are in either one or the other? One, 2, and 3, or any one of those numbers is in one or the other, or both. Okay. Okay. A has a 1 in it, and B has a 2 in it. Give me an element that's in both sets. Well, you can't, right? You can't because they're disjoint and their intersection is empty. The intersection is the empty set. Number 6. All right, so we've got all these, we've got some sets here. A is 3, 6, 9, B is 2, 4, 6, 8, C is 7, 10. U stands for universe, is 0, 1, 2, and then I dotted up to 10. So all of those numbers, all of those integer numbers between 0 and 10, basically, right? Okay, so we want to find A and B. And I think it's probably going to be easier for you if you actually write it out. A is 3, 6, 9. And we want to intersect that with B, which was 2, 4, 6, 8. So intersection. That symbol means and. That symbol means and. And you're looking at what numbers are in A and also in B. I'm looking at the 6. Is there anything else? That's it, right? That's the only thing that's in both. So we would say the intersection of A and B is the set containing 6. How about A and not B? Okay, so A and not B. So A was 3, 6, 9. And if we want to do not B, well, then we got to do everything else besides 2, 4, 6, 8, right? Not B would be 0 and 1, 3, 5, 7, 9, and 10. All right, 0, 1, 3, 5, 7, 9, 10. That's not B. That's everything else in the universe, right? Everything else in the universe. So now we want to find that intersection. Intersection means overlap. What numbers are in both sets? 3 and 9. Is that it? 3 and 9. Okay. The intersection of A and C. Well, A was 3, 6, 9. We're going to intersect that with C, which was 7, 10. Intersection means and, means overlap, means both. What numbers are in both of those sets? Nothing. What's our symbol for that? Okay. That does not mean 0. That's different. Okay. That does not mean 0. Now, let's do union. The union of A and B. I read that as or. I read that as or, one or the other, or both. So A was 3, 6, 9. We're going to union that with B, which was 2, 4, 6, 8. Okay. So again, you can kind of think about somebody's Christmas list. What I want this or this. All right. We'll just list everything out. Right. The union, if you think about the word union, it means to join. But we can join those numbers together, and usually I'll write them in numerical order. We've got a 2, a 3, a 4, a 6, an 8, and a 9. It doesn't matter that we'd have 6 twice. We don't skip it. We don't write it twice. You just write it. It's in that set. A or C. A was 3, 6, 9. We're going to union that with C, which was 7 and 10. Union means join. Just join those things together. We got a 3, a 6, a 7, a 9, a 10. Squiggle brackets. That means set. Okay, think about what this one says. The next one says A or not A. That's one way of reading it. What's going to be in either set A or not in set A? All of them, everything. Okay, what's the easiest way to say everything? That's going to be the universe. All right, that's going to be the universe. So we can kind of see that ahead. So you know, A was 3, 6, 9. We're going to union that with not A, which would be 0, 1, 2, 4, 5, 7, 8, and 10. So we're going to list everything, like you said. List out everything, or just call that U. That's the universe. Number 7 is kind of the same thing. Okay, a little bit more involved, I guess. A union with B. So I'm going to shortcut this and not write the squiggles. A was 1, 3, 5, 7, 9, 11. We're going to union that with B, which was 3, 6, 9, 12. So union means one or the other or both. We're just going to list them all out. So 1, 3, 5, 6, 7, 9, 11, 12. That's a union. Okay. And then the last one looks super complicated, right? You've got a lot of stuff going on. But basically, it's just an order of operations problem. Parentheses, when we've seen them in math, means do that first, right? It's order of operations. So this parentheses tells me to look at that part first. I've got the union of A and B. Well, I just did that, right? We literally just did that. 1, 3, 5, 6, 7, 9, 11, 12. We're going to intersect that with not C. Okay, not C is 0, 6, 7, 8, 9, 10, 11, 12. Everybody good on not C? So we look at that intersection. That means intersection. That means and. That means both. I see a 6 and a 7, a 9, 11, and 12. 6, 7, 9, 11, 12.